So I'm in Geographic Information Systems using Twitter. And GIS is an information system that takes spatial or geographic data, and it can use and it assigns them points and then coordinates, puts them on a map. And then the maps they have are lines, grids, polygons, and raster grids. And a line is simply many points strung together in a line like a roadway. Points can be anything like tweets just spread over a large area. And a polygon can be something like a state, a county, or a tract. And a raster grid is a gridded map that puts in polygons and points in them. And then the two types of API we use to download our data were the Twitter streaming variant, which is where you set a location and it will stream in as many tweets as it can in that given area, or search, where you search specific words in a certain area and it will give you them, but it has a limit of 1,000 words before it stops collecting. And this is an example of a point map. This would be an example of a line map, which is rows. And this would be an example of a polygon. And this would be a raster grid. So the reports we had were detecting non-personal and spam users on Geotag Twitter network, which dealt with the disadvantages when you stream these tweets. We don't know who we're getting. So we may get users who don't use it for personal life, or they're spam, or they're bots. And this talked about developing a way to get rid of them, which would be looking about the content of their tweets, the distance between their 2 points, and the speed at which they tweeted, or if they moved from point to point, to determine whether they were a spam user or not. And then beyond the geotag, situating big data and leveraging the potential of the GeoWeb, talks about how the data is not really that high in quality, and that using other data such as census data, you can compare it and see how well accurate it is and use the data a little bit more effectively. So geotag Twitter collection and visualization, it really was kind of very similar to the stuff we did, not much difference. It was just kind of an example for us to draw upon. And then geography of happiness talked about how you could use it with other data, and it took tweets, and based on what words they used and other software that determined what emotions were shown with certain words, they could determine by state which states were more happier on average. And then the materials you'll need are Node.js, which is a runtime environment, and libraries for the applications like MongoDB. MongoDB, which is a cross-platform document database, and that's where we put our tweets at first. But we can't use it in MongoDB, so we have to use MySQL and Python to get it into usable formats. And then we can put it in a tweet streamer, where we also use Python to code it. And then once it's coded and we have that, we can export it to ArcMap, which is where we create our maps. And then this is an example of Python code that was written by Chris, my mentor. And the methods were you would add a stream to the location. Yeah. You would add a stream in the location format of tweet streamer, so we get it within a certain location and not have a limit. And then you would take any data you got from there. You would filter it however you wanted it. So you have all the data you want, and what data you don't need is filtered out. And you can export that to ArcMap, and you start it up, and you get it there. Then most of the data, you can't use it first, and it won't show up on a map, because you need to calibrate it to X and Y coordinates to longitude and latitude. And when you do that, you can calibrate it to a map. And then when you get that, it can show up on any map, on that map. And then you can create the different maps from there. And so for the Call Me Cam one, we took the definition query of the program and sorted them out so that way they only showed up at certain times, and if they had the Call Me Cam hashtag. And then we would take snapshots of those maps at those times, and that's how we'd get them together. And then for the hashtag count, we simply inputted the filter so that only hashtags showed up. We recorded that, and then we graphed it. The convex hull, we take and we look for the the convex hole program, which is a spatial analysis. And what we do is we take points, put them in, and what we want the map for it to be inputted on, and it looks for the smallest polygon it can find that will either touch all the points or collect them all in, and then it creates that polygon. And then for the tracks and highway, we just took the map, and if it was in a certain polygon, like for the roads, we took and made them a 50 feet thick, no, 100 feet thick road, and any points that were in there would stay, and any that weren't in those polygons would be cut out, and they would be counted based on that. So this is the Call Me Cam, and for this one, we took and tried to look at like how quickly tweets could count up over a period of time. And for this one, this is the last period, and there's only 2 tweets left in this last 10 minutes. But as you can see, there was a total of 985. And based on that, we could find out there were 16.69 tweets per minute after the first hour that this came online, as it came online at this time. And then that's about 1,001 tweets per hour. And in a day, that's about 24,000 tweets about this, if it stays at that constant rate. We were originally planning to do diffusion with this, but the original tweet for this starts in California, which is way out of our data range, so we can't choose a start point for it. And also, we cannot show diffusion too well because Twitter doesn't rely on geographic diffusion from one point spreading out over the area around it. And then this is our tweets per census tract map. Which is a zoomable map. And we can see the number of tweets here versus the population. And it's colored to show areas of high density compared to its tweets. Like this one has 1,000 tweets, but it's only about 1,600 people. And there are gaps in a lot of our data, like right here at Oklahoma City and some of the cities outside of Colorado. Because of the way that the thing worked, we set it originally for Colorado, but it goofed up, got all these, and left out the cities. But another area that is in Colorado that doesn't have any is near Pueblo. And this is the Federal Correctional Complex. So this is the max security prison. That's the only place in Colorado where there are no tweets. So it comes up as a blank square in the middle of nowhere. And then that's that. And then this is the tweets per county. So you can look at, say, Denver County, and you get the tweets, the population, the county names. And this shows somewhat of a density of the tweets to the population. And unsurprisingly, the tweets that still seem to center near cities, especially in Denver. And then you have areas like New Mexico and Wyoming with nothing. No red spots. And this was, we took languages and we looked at which languages were not English and marked them by county. So this one, we looked at all of them, and we made a pie chart for the top 10 of those. And this gray one right here is all the other different languages that are maybe 1 or 2 tweets or just a few. And then based on which tweets were dominant, we could color them. So see, this one has a huge other, and this black relates to another language, and that's Swedish, while blue relates to Spanish. And it shows which language is the most dominant. And the grays around here are when multiple languages are about the same tweet ratio. And this is the Twitter versus highway system, which is where we took tweets that were within 50 feet on either side of a highway and mapped them. And it's pretty big, and there are, I don't think anyone can notice this, but there are small gaps in a lot of them that are grayed out of lines where areas where there were no tweets. But a lot of this area is still actually mapped out using just the Twitter tweets. There was, the ones that were blanked out the most were those away from cities. And city areas like Denver were pretty actually mapped out. So this is the area of tweets using convex holes. And when we first did this, we noticed that one user had the most tweets and dwarfed everyone, and even in our graph he dwarfs everyone. This is the top user. This is everyone else. You cannot see them, except maybe this one right here. And that one you can barely see is the second, which is Irish Sushi. The top is Scream Radius, who is actually a spam user. And we can partially know that because he covers all of the area, and the content of his tweets was mainly spam advertisements. If we cut him out to see the other actual users, it's very similar with the top and the second being a big difference. This is Irish Sushi, who is 3 times as big as the nearest one, and even then it rapidly goes to the point where you can't see anyone. And that's just a lot of people tweet within a small area and don't tweet all over. And with Irish Sushi, the only reason she's so big here is because we caught her tweeting in New Mexico and would drive up to Colorado. So she had a huge area, and otherwise she would be stuck in Denver, and that would be it. So this is the frequency of hashtags throughout the area. And the #1 hashtag was, unsurprisingly, Call Me Cam, which is why we chose it. The other ones were jobs, Denver, Colorado, veteran jobs, and stuff like this, which is interesting, but it kind of shows the top is still pretty big compared to the others, but it's not as shown as the area where it's just a complete crash. And then the tweets per second. So we took the number of tweets we had and divided it by the time that it took to get all these tweets, and we came out to about half a tweet per second. And the actual number of tweets that are given by the Twitter engineering blog for tweets per second is around 5,700. So we get about 1% of all the tweets. So we don't get much, which is interesting because that's just how small of a base we get. So this is tweets on Ukraine. Like, for example, the plane that got shot down over, which is about when this happens, which is why there's such a big uptick. And it kind of shows how you can map important events by how Twitter feeds spike. Because there's almost no tweets until then. Yeah, no. So here are my references. These were all the research cited, hopefully correctly. And then this is my acknowledgments. I want to thank NAS because they helped run FSI, UNC for letting us be here, the Moores family for helping finance me here at FSI, my research sponsor, who I unfortunately just forgot their name, ouch. And I'd like to thank Topher for being my mentor and everyone else at FSI. And that's all, folks.